My name is Adam Lester. This is Teach 2 Energy Lesson for SMED301 Fall 2011, Janice Davenport. Good afternoon, everybody. I am Mr. Lester. I'm honored to be here and would like to thank Miss Hammer for allowing me to come back and talk to you all again today about some pretty neat stuff. We are going to talk about energy. So, who knows what the number one energy source is for our planet? Yes. The sun. Good. Great. Well, let's take a look at something real quick. Let's say we have Earth and we have the sun. At what point on the Earth's surface is the sun the brightest? Right in that area where the light is directly hitting the surface. See that big circle there? Okay. Well, what do you think is going to happen to this circle as the Earth gets further away from the sun? Well, let's see. Gets pretty big, doesn't it? Well, here's something. Let's go back to here. What would you say is going to happen to this energy as the sun tilts? Changes shape, huh? Does that look as bright to you as it did before? What would you say about experimenting a little bit with some sun and earth models of your own? Sound good? Great. Alright, does everybody remember the popsicle sticks that we gave out at the beginning of class? This is how we're going to determine our groups. Those of you with a star on your popsicle stick, you all are grouped together. Everyone with the letter A and the smiley face, you all will be a group. Everyone with a heart on their popsicle stick will be another group. The next group should have the letter B, the number 1 on their popsicle sticks. And the last group should have the letter C with the number 3. Everybody gather your things and go ahead and get into your groups. So, how many of you have played with flashlights before and really stopped to observe the different patterns of light that they make whenever you hold it close to or further away from, say, a wall or anything like that? Most of you? Yeah, we've all had flashlights at some point or another. So, we are going to be handing out some materials. We'll be giving out flashlights, protractors, and graph paper. Those of you that get a flashlight will be holding the flashlight for this experiment. Those of you that get the graph paper will be drawing the different patterns that we're going to have. Those of you that are getting the protractor, you're going to be responsible for holding that protractor for the flashlight person. And the fourth person will be observing to make sure everything stays consistent. So, what you're going to do is, whenever you get these materials, the protractor holder is going to take their protractor and they're going to hold it straight up and down onto the center of the graph paper. The flashlight holder is going to hold their flashlight at 3 different angles, straight down, it should be 90 degrees, pick 2 other angles, and then shine that light down onto the protractor and onto the graph paper. That person that got the graph paper should then take their pencil and draw that circle or that light pattern on the graph paper and label it with the angle. Each of these angles should be held at the same distance from the graph paper. Next, once those are drawn and labeled, you will hold the flashlight at a specific angle and draw the patterns at 3 different distances from the graph paper. Once those are drawn and labeled and everybody is finished with their observations, you all will need to hold up your flashlights and we will come and collect the materials, and then we'll see what everybody was able to come up with. Now that we've got our circles drawn, from those circles, what can you tell about the amount of graph paper that was covered whenever you changed the angle of the flashlight? Good job. More area was covered whenever you changed that angle to a more horizontal slope. Why do you think that is? Well, it's not less light that's emitted because we didn't change the amount of light that came out of that flashlight. Remember? It was just spread out over a larger area. What did you notice about the brightness as you changed angles? It got dimmer. That's right. Why do you think it got dimmer as you changed the angle? The same reason. The same reason that it covered a larger area. You take the same amount of light, bring it over a larger area, and once it spreads out it becomes dim. Good job. As the intensity of the light decreases, what would you say about the heat that it would emit? Right. The less light, the less heat. So if the light is dimmer in one area than another, would this area be hotter or colder in a brighter area? Less heat, colder. Good job. What can be said about the heat found at a more horizontal angle? Now don't forget, the more horizontal the angle, the dimmer the light. Right. Dim light equals less heat, so it would be cooler at a more horizontal angle. Great job. If your paper were the actual surface of the earth, how would you describe this change in how bright or how strong the light is? Right. Where there's light, there's day. Where there's light, there's heat. Right. Where there's more light, there's heat. Good job. Anything else? Okay. What about any other ideas on how much light we see on a particular surface of the globe? Okay. Let's take a look at this globe. And don't forget that the globe does not sit straight up and down. The globe is tilted. Now let's turn out the lights and let's take a look at our globe with our sun. Alright, our sun is out here in the solar system, and here's our Earth. Where the light strikes the Earth, what can we say about that time? Daytime. Right. So as our Earth spins, what would you say about the Earth where the light stops hitting? Nighttime. Okay. Now, as the angle of the sun changes in the experiment, like we just did, what does this do to the heat energy transferred to the Earth's surface? The amount of light changes in the different areas. There's less light up top here than there is right here towards the bottom of the globe, the southern hemisphere. Good job. Let's turn our lights back on. Now remember our angles. Up here in the northern hemisphere, is that a more horizontal angle or is it more of a direct sunlight? Horizontal. So since it's at a more horizontal angle, there's more indirect light. What would you say about the temperature? That's right, it's definitely colder up here than it is down here on the southern hemisphere. So let's say I live in Glasgow, right here on our globe. Right here. If the globe and the sun are positioned like this, what clothes should I be wearing at this time? That's right. Probably winter clothes. At this point, Glasgow is receiving a lot of indirect light from the sun, and therefore it is colder. Good job. If I were to jump on a plane and travel south down here to Brazil, I've always wanted to go to Brazil. Same situation, Earth tilted, here's our sun. If I were to go to Brazil down here, what clothes should I pack? Probably summer clothes. Yeah, you're right. It receives a lot more direct light than Glasgow is at this point in time, and therefore it is hotter. Good job. At this time, we have a little handout that we're going to give to you all, and it's just got a couple of questions on it. Let's see if we can figure these out. Go ahead and make sure that your names are on them. I'm going to pick them up after you get finished, so that way I'll have them. And well, here you go. Let's see what we can do with this information.